June 2026 brings an incredibly dense lineup of new video games, nearly all carrying a firm $69.99 price tag. Processing these heavy releases will demand serious physical energy from your system. Traditionally, a high-end graphics card was the single most important factor for performance. However, the latest wave of software shifts that balance, placing new demands on the rest of your system. The components now determining whether a game runs smoothly or stutters are your processor, the speed of your memory bandwidth, and your Gen 4 NVMe storage drive. Developers are now standardizing Unreal Engine 5 across the industry. They are programming pedestrian AI using complex neural networks instead of simple routines, and simulating entire physical ecosystems in real time. This creates massive data logic problems that a GPU cannot solve on its own. This scatterplot chart maps out the financial risk of this month's releases. It plots the purchase price on the bottom axis against the actual computational load required to run the game on the vertical axis. Look at the cluster in the top right. These are the heavily marketed AAA titles. They demand the absolute maximum out of your hardware while asking for top dollar upfront. Down in the lower half of the chart, you find a scattered distribution of highly optimized indie releases and closed ecosystem games. They cost significantly less and require a fraction of the computational power. Because the computational load is now split across the entire rig, buying a game without checking your specs is a financial gamble. You need to audit your specific hardware before committing to any of these $70 titles. Let's evaluate the absolute heaviest titles hitting PCs right now: Cyberpunk, Project Orion, and the Gothic 1 remake. Alchemia Interactive rebuilt Gothic from the ground up using Unreal Engine 5's world partition system. The non-player characters now operate on neural networks, allowing them to make complex, dynamic decisions instead of walking along pre-programmed paths. Processing that much live logic requires serious multithreading. If you want stable frame rates in densely populated areas of the map, an Intel 13th Gen or Ryzen 7000 series processor is the absolute minimum baseline. This diagram shows a standard rendering pipeline. Running these games on an older processor creates a severe traffic jam. The graphics card sits idle because it is waiting for an underpowered CPU to finish calculating the heavy AI routines. Heavy computational demands also extend to physical simulation games like Hell Let Loose Vietnam and EA Sports UFC 6. These simulators calculate thousands of micro-collisions. Hell Let Loose models the destruction of individual leaves from a nearby blast radius. UFC 6 relies on real-time fluid dynamics to track sweat and blood reacting to gravity and impact velocity. To keep those simulations running smoothly, you must stream textures incredibly fast. A high-end Gen 4 NVMe solid-state drive is now mandatory just to stream these physical assets and prevent micro-stuttering. Participating in the high-end PC gaming space this month requires a holistic, expensive system upgrade. A powerful GPU alone will not fix a bottleneck in your memory or storage. If a complete PC rebuild is out of the budget, the primary alternative is migrating to tightly optimized platforms like the Nintendo Switch 2 and standalone VR. Nintendo is pushing its new console immediately with heavy titles like Star Fox Galactic Return and a massive port of Final Fantasy VII Rebirth. Square Enix and Nintendo managed to fit a 150GB open world onto a handheld device while maintaining high-fidelity visuals and a stable frame rate. Look at this schematic comparing hardware memory layouts. Instead of splitting tasks across separate memory blocks, the Switch 2 uses a custom NVIDIA chip with a unified architecture. The processor and the graphics unit pull from the exact same pool simultaneously, eliminating traditional memory choke points. The strict trade-off here is reliance on proprietary upscaling. The console only achieves stable 4K output when placed into docked mode, which allows the AI upscaling software to engage and boost GPU clock speeds. We see similar optimization strategies in the standalone and tethered virtual reality markets, specifically comparing Meta Quest 3's Downtown Club to the PSVR 2's The Boys. The Quest 3 delivers simulation racing without cables. The headset uses a rendering pipeline called Asynchronous Space Warp 3.0 to calculate driving physics at a locked 120 Hz, minimizing motion sickness on a standalone device. The tethered PSVR 2 provides a different capability through foveated rendering. The headset tracks exact eye movements, rendering only the specific spot you stare at in high resolution, saving processing power on the blurred periphery. These closed ecosystems successfully deliver AAA experiences, but they require you to trade raw, customizable computing power for a highly controlled walled garden optimization strategy. Simple clicker mobile titles are being replaced by full-scale Unreal Engine 5 MMORPGs, driven by the launches of Guild Wars Reforged and RF Online. These games render massive 50 versus 50 battles in real time, syncing your phone directly with live PC server infrastructure. Developers achieve this using a dynamic AI level of detail system. To maintain 60 frames per second on a phone, the software intelligently strips away armor details and geometry from distant players when the screen gets crowded. This thermograph visualization illustrates the severe hardware trade-off. Processing live 3D server coordinates pushes standard smartphone chassis to their extreme limits, forcing the central chip to radiate intense thermal energy directly into the battery sector. Running these games on high settings will drain a standard 5,000 mAh battery in under 2.5 hours. Subjecting a phone to this level of heat and rapid discharging permanently degrades the battery's maximum capacity over time. Running cross-platform Unreal Engine 5 on a smartphone represents a significant technical leap in data synchronization, but it creates a physical toll on the device. A general list of the month's best games is useless. Your purchases must be strictly dictated by the specific platform you own. This flowchart breaks down your purchasing options based on a single starting point. What is your actual hardware reality? If you have a high-end PC with a 13th Gen or Ryzen 7000 CPU and a Gen 4 SSD, you are cleared to purchase the extreme load Unreal Engine 5 titles like Cyberpunk Project Orion and the Gothic 1 remake. If you are running an older CPU, skip the massive open worlds entirely. Instead, invest in games running optimized physics architectures like Sifu 2 or Copa City. For handheld and VR adopters, proprietary ecosystem games will deliver full AAA scale without requiring a single PC upgrade. If you need to optimize your budget, look toward the $15 to $25 bracket, which features tightly designed experiences like Hollow Body and the Dave the Diver expansion. These indie titles rely on smart design rather than brute-forcing hardware. Hollow Body uses audio ray tracing to physically bounce sound waves off metal and concrete, creating intense environmental awareness using very little processing power. A game is only a masterpiece if your hardware allows it to be. Audit your limits, ignore the marketing hype, and align your budget with the reality of your current technology.